的天，8月正午的阳光都没你耀眼。热爱105度的你，滴滴青春的蒸馏水。
Okay, for introduction, in differential calculus, the related rates problem involves finding the rates at which quantity changes by relating that quantity to other quantities whose rate of change are known. So it is mean that the related rates problem analyzes the rates at which the function change for certain instances in time. These problems generally have two or more functions that we have to relate the functions themselves and their derivatives. Hence, the name is related rates. The related rates is often used in science and engineering to relate the quantities to each other. The related rates also help us to determine how fast or how slow a certain quantity is changing by using the rates of change of a second quantity. It is also useful when we have two related quantities and one of their rates of change is much harder to find than the other one. So supposedly the related rates are so important because there are so many real-world applications of it, like a snowball melting, a ladder falling, a balloon blown up, a stone creating a circular ripple in a lake, and two people moving away from each other at the right angle. So that's all for introduction.
Okay, so now I will drink this water, but before that I will tell you the radius for the cap of the bottle is 1.5 centimeter, and the radius of the base for the bottle is 3 centimeter. The height of this bottle is 17.5 centimeter, and the height for the water inside the bottle is 16.4 centimeter. Okay, so now I will drink the water while record the time. Okay, so first I'm gonna put this one. Okay, so I will drink and record. Okay. Okay, 1, 2, 3. Okay, so yeah, the time recorded is 4.90 seconds, and yeah, now I will record the height of the water after I drink it. Okay.
Super Idol 的笑容都没你的甜，8月正午的阳光都没你耀眼。热爱105
The height of the water after I drink it is 10 centimeter. Yeah, that's all from me. Thank you.
Alright, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So I will move to what we want to solve it. So let's go. So based on video first, he say we have drink the bottle water. So we got the A is 1.5 and B is 3 and H is 16.4, H1 is 10.4 and H2 is 6. So we want to find what is the dV over dt. So first has drink the water 60.4 and then have left 10 centimeter. Okay, in 5 seconds. So we got the dt is negative 1.28 centimeter over second. So this is the volume formula for the bottle. So we got yes pi over 3 multiplied with H2 plus multiply in bracket a power of 2 plus ab plus b power of 2 close the bracket plus pi multiply with h1 and multiply with b power of 2. So we input the value of A, H1 and H2. So we got this 3, 6, 5, 4 and B. So we easy it and then become like this: 4.4 pi plus 3 pi B plus 12.4 pi B of 2. So we differentiate it, then become 3 pi plus 24.8 pi B. We do all this because we want to solve it to find the dV/dt by dV over dB equal with dV over dt multiplied with dt over dB. So this will become this dV over dt multiplied with dt over dH multiplied with dH dB. So and then yes, this is dV/dB, and then this is we want to find the dH over dB. We got 82 over 15, and then we want find the dH dt, but in the formula is dt dH. So we find it by 1 over negative 1.28, so then become negative 0.78125 seconds. So let's move to Arshad.
Okay, next I will continue Imran's work. Assalamualaikum warahmatullahi wabarakatuh. In this video I will continue the Imran's work. So in this video I will find the value of dV/dt. So as we know, the value of dV/dB is 3 pi plus 24.8 pi b, and the value of dH per dB is 32 per 15, and the value of dt over dH is negative 0.78125 cm square, and the value of B is 3 cm. So we just put the value in this formula, so the answer will get this, the value of dV over dt.
Okay, what can be determined from the previous statement and previous broken statement and so on? Okay, first of all, related rate help us to determine how fast or slow a certain quantity is changing. For example, the water dripped by a faucet can be determined how fast it's decreasing. Okay, nextly, the rate of change must always be respected to time. For example, dV over dH, dV over dt. Okay, thirdly, related rate can be applied in many different types of object or environment. For example, we can measure the rates of water decreasing in a tank by using this method. And lastly, related rates mostly used in any branch of science, for example, engineering. It is because related rates often relate two different quantities to each other.
热爱105度的你，滴滴青春的蒸馏水。Super Idol 的笑容都没你。